So I am Dave Liddament. I will be talking about modernising legacy code at PHP Southwest. This is a story from a few years ago where I was working on a project that had been going for maybe 8 or 9 years, and it started on Laravel 4.2, and 8 or 9 years later it was still on Laravel 4.2, and we needed to upgrade it. And after probably years of saying we really need to upgrade it, the management said that is a great idea, go and upgrade it. And I was like, shit, now we've got to work out how we're actually going to upgrade it. And this is a story about how I went through that, how me and the team I was with went through that process. And finally, on February the 24th, 2023, this was one of the final commits of it, huge amounts of changes, and we released it. And we were super excited, and the Laravel team was so excited as well. They upgraded Laravel from 9, which is what we'd got to 10 to celebrate us finally getting to 9. And there we were, back in legacy hell again. But, so anyway, this is the story, and we're going to cover these topic areas. The first thing is what I'm calling code prehab. So this is to get our code into a state ready to do these kind of big updates to our code base. Then we're going to see how I did it. And don't worry, people who love a bit of static analysis and abstract syntax tree action, there is some of that later when we're talking about making custom vector rules. So, code prehab. If you were going to have certain kind of operations, like planned operations, what might happen is the surgeon might give you a set of prehab to do. So these could be exercises, these could be lifestyle changes. And the purpose of that is to increase the chance of a successful operation and reduce the risks. And if we are doing a large update of a code base, we might need to do some, what I'm calling code prehab, to get the code into a good state to make the chance of the upgrade more successful and have fewer chances of introducing issues and problems. So our particular project had been going for maybe 8 years, and there were lots of ideas in there. There were lots of things that we tried out, and ultimately we decided we didn't need. So our code base was strewn awash with like dead code and rubbish code that we weren't using. And the first thing we wanted to do was, before we upgraded everything, we'd say, is there some code that we don't need anymore? Because if we don't need that code, we can just chuck it away now, and it makes the amount of code that we need to upgrade a lot less. And what we did is we used this concept called tombstones. So we went into every single public method and every single protected method, and we would add in some code like this: tombstone reporter, : trigger, and then the name of the class and the method that we were in. Now, we didn't put these here by hand. We actually used a tool called Rector to put all of these in, and we talk about Rector later on. But what would happen is we would add this to every single public and protected method. And what this would do is it would, if you actually went into this, and it would be the first line of every method. And if you went into, say, this calculate method, and we would then call this tombstone trigger to say we have triggered the method price calculator : calculate, and we would store that in the database somewhere. So what happens is, as we are using the code normally, all of the methods that we called would be put in a database table. And then at a later stage, we could query this database table and to get triggered tombstones.json, which would be the fully qualified name of the class plus the method name. And then we would feed that into a Rector script, and then it would go through, and for every item in the triggered tombstone.json, it would go and find that method and say, if there was a tombstone reporter call, we can now get rid of it because it's been triggered. So what would happen is we'd set up the code with all the tombstones, and the important thing is we'd want to really use it in a real environment, like a live environment, because we only want to know what people are really using. So we wouldn't, for example, run the tests because the tests might be testing code that isn't used anymore. So we would do this. What we initially did was we put it on a staging environment and we got the sales team to go through their demos because we knew everyone would be using that code because that's what the sales team demos, the sales team at least, were using it. And that got rid of like hundreds and maybe thousands of these tombstones. And then we put it onto live for a few hours at a quiet time. And then we got a list of more tombstones and we removed those from the code. And you kind of do this process over and over time. And at the end of it, you've got just tombstones left, which are things, methods you might need to investigate to see if they're still used. So for example, we found tombstones in code that was part of quarterly reporting, but at that point we hadn't done the quarterly reporting. So you don't just remove everything because the tombstones are still there. You've got to kind of assess each one. But there was quite a bit of code in there that we decided we didn't need. And all the code that we threw away meant that was less code to worry about for the upgrade process. And when we were deleting our code, rather than just deleting it all in one go, we did try and delete it kind of roughly feature at a time. And then that would be in individual Git commits, and we would kind of have this convention remove and then whatever it is that we've removed. What that did mean is if at a later stage we wanted to get that back, at least we'd have some reference code. So we probably couldn't use it directly because of the upgrades we're going to do, but at least it would be there, so it'd be pretty quick to copy it from. So all of the features, all the bits of the code that we didn't want, we would bag up neatly into individual commits, and they would be there in the Git history if we ever changed our mind. So the code prehab is kind of three things. There's tombstones, type coverage, and test coverage. So next, we'll talk. Is everyone kind of happy with the tombstone principle? Yeah. And actually, it's probably worth doing on all of your code from time to time because there will be bits in there that you're not using anymore, and you can just get rid of it, and it's less of a maintenance burden in the future. The other thing we wanted to do was increase our type coverage. So if we were to look at this code here, I'd say it had 0% type coverage. And by that, I mean we don't really know the types of any of the variables in here. And we could make educated guesses, but that's the best we can do. So we don't know what $users is. We can see that we iterate over it, so it's at least some kind of iterable. Maybe it's an array, maybe it's a collection. And it looks like we're returning something that we joined, so we're probably returning a string, but we don't know for sure. And then is getUser, well, that might be a string as well. We could guess, but we don't know for sure. Now, if we contrast that with this code here, what we've done is we've added type declarations to the function. So we say $users in this case is an array, and whatever we're returning from here is a string. And where there are limitations in the language, we add the additional type information via the dot block. So what we're saying here is $users is an array where all of the keys in the array are type int, and all of the values in the array are of type user. And you might think, oh, this I would call 100% type coverage because we can work out the types of everything in there based on the type information. And you might think, well, so what? What benefit do we get from having 100% type coverage? Well, suppose as part of our upgrade, we've identified that we're going to change the method name on the user class from getUser to getUsername. We could just do a full text search and replace, and everywhere where it's getUser, we update it to getUsername. But we don't know that will work for sure, but because there could be another class which isn't called user, which has a method called getUser, and if we update that, then that will stop working. And then sometimes so that's why we really need to know the type information. So if we have a 0% type coverage, we can see there's a getUser call here, but we're not 100% sure whether that is the one we need to change. So maybe a developer who knows the code well could look at them each in turn and make a decision about which needs changing and which doesn't. But that's quite a long process. Whereas if we have 100% type coverage, we know that this getUser is a method call on the user class. So we know that's the one we want to change. So we can safely change it automatically. And we don't need to, when we know that if that's the change we need to make, then if our code worked before, it will work again. So the benefit really of 100% type coverage, if we knew the types of everything in our code base, it means we can make refactors like renames completely automated and completely safely, and we don't need any tests. So if this worked before and we know that type coverage and everything's correct, all the type coverage is correct, we can make this change and we will know that it will work in future. But you still definitely need tests. I think if we hadn't had tests for this project, it probably would have taken 3 or 4 times as longer. And when we got it live, there probably would have been many bugs out there. So if you have a big legacy project and there were no tests at all, probably my starting point would be something called smoke tests. So a smoke test is if it's an API, you just try and hit all of the API endpoints and make sure you get something that isn't a 500 response code. If it's a web application, you would try and load each of the pages and make sure that it doesn't crash. And that would be your starting point, and you'd probably get a reasonable amount of value from that. But what you really want to do is then take those smoke tests and try and add in checks to make sure it's actually functioning correctly. What we want with our tests is the confidence to make a change, and if all the tests pass, then we know that the system is really going to be working. And certainly if you're doing big upgrades, then you're going to be making lots and lots of changes. So the more tests we have, or the greater the test coverage, the more likely that when we make a change, if we've made a mistake, our test will tell us that we've made a mistake, and then we can go fix that before it goes live. And if we have a test suite that we're so confident in, it means we can release quite frequently. And that also is beneficial, as we'll see later. So the first stage is code prehab. We're going to get rid of all the dead code, for example, using tombstones. We're going to increase our type coverage, ideally to 100%. And we're trying to get our test coverage as high as possible. I would, again, if you don't have any test coverage at all, then look at the smoke tests. Then I'd probably focus the tests on the bit of the code which is most frequently used, or the bit where if you make a mistake, it could be costly. So anything around like calculating the price of something, for example, would be somewhere where I'd focus test coverage. So this is the code prehab stage. I mean, this is basically good software development practices, get rid of code you don't need and have good type and test coverage. So the next stage of our process, once we did that, was to plan how we're going to get from where we were to where we needed to get to. And the first thing is always check if someone else has done this for you already, and we can go and pinch those ideas. Now, this was a Laravel project, and there's a tool called Laravel Shift, which takes you from one version of Laravel to the next. You just give it your code, and it does some magic, and it comes back at the next version. Now, that didn't really work for us, and that's not actually Shift's fault. It's because over the 8 years, we'd kind of veered off what would be the Laravel way of doing things. There was a time we thought we were going to switch over to using Symfony, so we started making decisions as though that was the way we were going to go. And then after a few years, we decided that probably isn't the best idea. But we were kind of in this bizarre somewhere between Laravel, somewhere between Symfony. So when we gave it a Shift, it didn't really do that well. And we'd kind of moved off the 4.2 way of doing things as well. But if you're on the Laravel project and you have stayed doing the Laravel way, then definitely have a look at Shift. It doesn't even cost that much, to run it. So it's definitely worth the cost just to see if it works or not. There's another tool called Rector. That I think actually is the old logo of Rector. I should update the slides. But we're going to look at that in more detail, and that is a tool that allows you to automate a lot of refactorings. then maybe we're just going to have to write our own scripts to do things, and there will always be a bits of manual intervention. So I think on this particular project, we managed to automate like, I don't know, probably 80% of the code changes, and that probably took 20% of the time. And the remaining 20% was manual, which took 80% of the time. It's one of those 20-80 things. So yeah, you definitely want to automate as much as you can. So yeah, Laravel Shift, if you're using Laravel, check out Laravel Shift. Rector, we are going to have a look at Rector in more detail. But it comes with a number of rules anyway. So the rules, some of them are similar to what you can do in an IDE. For example, we've got a rename method Rector, and you would, what that would do is you'd say, I want to go from the old name to the new name, and it would go through your entire code base and it would make the changes, providing, of course, it knew the types, which is why you need that 100% type coverage. So I mean, probably by now there's probably 400 rules. They keep adding new ones all of the time. And they can do simple things like what you might get in your IDE, but they can also do more complicated things. For example, it can update this code it can change if else and make them early return pattern if you wanted to. So it is very powerful in what it can do. And you might say, well, so what? I mean, I can do a lot of these things in an IDE. But the benefit of Rector is what happens is people could script up, or they could configure all of the vectors that you need to make to do a migration from one version to another. And then they could pass that file over to someone else, and then you just run Rector with that config file. So that's what the benefit of Rector is you could be in a situation where if you were a library maintainer, and you say, in order to go from version 1 to 2, you need to do these changes. Oh, and by the way, here's a Rector file that you can, a Rector configuration file that you can then run on your code base, and it will make all the changes you need to make your code that was, you know, talking to version 1 to talking to version 2. So this is a real benefit, I think, of Rector over your IDEs. And if you want to run it, you just install it. You do composer require dev rector, and then you run it for the first time, and it'll say, I can't find any config file. Do you want me to generate it? And you say yes, and then it generates a file like this, and then you can just put in all of the rules. You can configure all the rules that you want it to run. So this one here will do a method rename where it's going to update belongs to belongs on the model class. So it's quite powerful what you can do. This is all auto-generated, and it's just this bit here that you'll fill in with the rules that you want it to run. And what that would do if we actually ran it is it would then look at our code base, and it would say, these are all of the changes I'm going to make. So it'd make a huge diff of all of the things it's going to change. And it would tell you which rules it has applied. And it'll go through however many it finds. So what I would recommend if you are using Rector is actually just to do one rule at a time, because otherwise the diffs are huge and it's much more difficult to check that it hasn't done something wrong. These kind of things it normally gets right, but some of the more complicated ones, you've got to keep an eye on it, especially in code where you don't have very high type coverage. So then you can get things called rule sets, and they are a combination of Rector rules. So for example, if you are doing Symfony updates, then somebody's made a Rector Symfony library, and someone has also done one for Laravel as well. So if you don't want to use Shift, you can have a look at Rector, and it might be able to help you out doing these upgrades. And if you looked inside one of them, it would just be a whole, if you wanted to use one, then you would take your Rector config file and you'd say, I want to use a Rector rule set and then the name of it, and it would just run all of the rules within that rule set. And if you want to think, where do they come from? If you read the upgrade document, so this is the Laravel 9 upgrade document, it's saying we're changing from with Swift message, it's been renamed to with Symfony message. And then if you looked in the Laravel 9 upgrade Rector rule set, somewhere around line 89, you'll see this code here, which is saying I'm doing a method called rename I'm going from with Swift message to with Symfony message. So that relates to what was in the document here. So it's quite powerful, and what it does mean is somebody else just has to do all the work once, and then they can share that with everyone else, and everyone else doing the upgrades can just make use of this work. And as I said, some of the work you'll still have to do manually, and maybe you'll create your own scripts to automate things, and maybe there are things that are genuinely you do have to do manually yourself. And it's just making an assessment. One process I do quite like is how Symfony do their upgrades. I think they do their upgrades in the best way possible. So what happens is with Symfony, every 6 months they release a new version. And if you're going up a major version, then you would go from, so if you're going from 5 to 6, the highest minor version in Symfony would be 5.4. And then the next version would be 6. And what you can do in Symfony world is if you upgrade your code to 5.4 and you run it and there are no deprecation warnings, then you can safely upgrade from 5.4 to 6. So it is a really mature way of doing upgrades. And I think this is what everyone should be aiming to do, really, how Symfony do it. And of course, the Symfony thing, the key thing is to fix all the deprecation warnings. So you would get a deprecation warning by running the code. And this is a case where the greater the test coverage is, then you would just run all your tests. And all your tests would then trigger all the deprecation warnings for the code that you needed to update. What I have also seen now is when PHPStan upgraded from version 1 to version 2, it created, PHPStan made an upgrade. So this is for people who are writing custom rules for PHPStan. So when it went from version 1 to version 2, you had to change things about your custom rules. And what PHPStan did is they had a PHPStan rule set, which would go through and look in your PHP custom rules and tell you, oh, this no longer works, this is deprecated. So again, that's another good way of doing it. And the benefit of doing it in a static analysis kind of way is you don't need the same level of test coverage. But there will be some things you can only do with actually running the code. So anyway, I love the way Symfony do this kind of thing. And if you're making your own libraries, then have a look at that and see if you can apply those principles. So back to what we were working on. We wanted to go from 4.2 to 9. So I could have tried to go up every single version. So 4.2 to 5 to 6 to 7 to 8 to 9. Rightly or wrongly, I decided that is probably going to be more effort than it's worth. That might have been a bad decision. So what I did is I said, well, this is everything in 4.2 world, and this is everything in 9 world. What are all the changes that I needed to make? And I made a whole long list of changes. I mean, this is just a little bit of it, but these are all some of the tasks that needed to be done. And then for each task, you're asking yourself these questions. Can we automate it? Hopefully the answer is yes. If we can, is there an existing solution? So for example, has someone made a Rector rule set that will do that? If yes, go and use that. If not, then you've got to ask yourself, is it worth me creating like a custom way of doing that? And that will largely depend on how experienced you are with using tools like Rector. And I would say even at the start, if you say, oh, I'm not really sure it's worth it, if you keep practicing and keep doing it, then actually more likely this is going to become yes as you get more experience doing it. So anyway, whatever you identify as automating, you will automate, and everything else you'll have to note that this is something you're going to have to do manually. Now, this was the big mistake that I made on this process. We were in development. Then, because we were moving so much stuff around, we basically had a development freeze while we were doing the upgrade. So we had development, all development stopped while we had this upgrade window, and then after that was done, development continued using Laravel 9. There's a number of problems with this. First of all, we had maybe a month and a half where we couldn't do any active development. Okay, if there was an urgent bug fix, we would do it here, and then we'd have to remember to do it there, so you're kind of duplicating your work. But the other problem is this is a very high risk release. You know, we're changing everything. So we've really got to have a high level of confidence in our testing. And of course, if our test did find some problem, and then we have to go back and make a change, really we need to test everything again. So the bigger that blob is, the more riskier it is to release. So we really want to be looking at, can we break things down into smaller bits? And you might think, if we're going from 4.2 to 9, there probably is nothing we can do. And that's what I thought, but in retrospect, I was wrong. So smaller deploys, I think, would be much better. Even more so if you have a test suite that gives you confidence that if it passes, that there won't be any trouble when you go onto live. And the other benefit is, if we do find problems here, our search space for where that problem is a lot smaller. So the ideal thing is we do a bit of work, we put it live. This would be just long enough for anyone to find any real bugs and then report them. And then we can go back, and because we're sort of a big blob, it's just a smaller blob, it's probably easier to find where we've made a mistake. And the other good thing about this is, okay, these little pauses in feature development, but if we've got a new feature we need to do, we can just drop it in here. So this is what we're aiming for. And things that we could look for, I'm just going to give you ideas because every update, every upgrade is different. But imagine we've got our currently deployed versions, the currently supported versions, and the new supported versions. And what we might do is try and look for patterns, things that are in both. So for example, if we wanted to go from framework version 12 to 13, and we're currently using 8.1, but actually 12 can use 8.1 and 8.2, and version 13 can use 8.2 and 8.3, well, what we could do is we could just upgrade our PHP version, leave everything else the same. And then the same thing we do with the PHP unit. So we could do the PHP unit update, and then finally we go from 12 to 13. So our upgrade blobs might look a bit more like this. So instead of one big thing, we can split it out. And again, you've got to look at all your dependencies and work out what works with both, and then just try and update things gradually. But even in my project, where because we were going from 4.2 to 9, there wasn't any common version of PHP between those two. It just didn't work. But there were still things I could have done to break things into smaller chunks, and also to have a shorter kind of code freeze window. The first thing, for those who remember Laravel 4.2, everything was just in the global namespace. You didn't have anything. They were all in different directories, but all the models were in the global namespace. Everything was in the global namespace. But I could have moved things around. I could have moved them to where they could have been. I could have moved all the models and then made a release with them all in app, model, and then name. And that would have worked in 4.2 world. And I could have done the same for the controllers. I could have done the same for all our services. So I could have had lots of releases where I was just moving code to where it would live in the Laravel 9 world. And that would still work largely on 4.2 as well. So I could have done that. The other thing I could have done, what I absolutely should have done, is I could have gone on to the process, or whoever could have gone on to the process of writing the automation scripts while people are still doing software updates. There's no need to pause updates while I'm writing scripts to automate it. And the benefit of doing this is then our window is a lot shorter, because what I was doing before, half of this was just me writing the scripts to automate it all, and that didn't need to block ongoing development. So these are the kind of things you want to think about. And if you think that you can't break it up into something smaller, you're probably wrong. You just got to think about it a bit more. So that's the planning phase. What tools can help us? What tasks do we need to do? How can we automate them? And how can we break them down into smaller steps? And then once you've planned it, it is actually just to go through the plan. There are some tips. I would say be systematic about it. Aim to do one of the changes at a time, both manual and automation, because if you've got multiple things going on, then it's just a whole world of pain. You get Git commit merge problems and conflicts and all of these things. So I just try to stay focused on one thing at a time. And when you're going through, if you suddenly see, there's another change that I need to make, then I'd note that down, and that's another task to do later. And what you can also do is put to-do comment in. So what we do is put to-do L9, and that's something we would then grep for at the end. So we knew we hadn't finished this release until there were no more to-do L9. So all of our tasks, and this was kind of like a safety net. So if we saw something that needed to be done, but it wasn't the exact task we were doing now, we would keep focused on what we were doing, note it down, and have that to-do L9, and we'd know that because we do a check at the end, we'd know we wouldn't miss that. So it just gave us a bit of comfort. I would use git commits, even if you squash them later. And I just work on upgrades. I just fix the deprecations. You don't need to immediately use new features. So for example, we were going from, PHP 7.4 to, I don't know what we aimed up, but maybe it's 8.2, I can't remember now. But there was a whole set of new PHP features like property promotion, which we want to use, but they shouldn't be involved in this upgrade process because it just makes the git diff even bigger and that space where a problem can be even bigger. So we just focus on what we need to do to get things working, and then at a later stage we can then go and apply some of the nice things that later versions of PHP offer. We're just trying to make sure we don't use anything that no longer works in PHP. And of course, as I said earlier, just do the minimum amount of work between releases. That's what we're aiming for, and then get it released. So there will be some times when, because of the way you've done things, there will be no out-of-the-box Rector rules to help you. So then you need to create your own custom ones. And it's not actually that difficult. So one example is, in the old way, we had some code that said this belongs to user. So we've got two models. We've got car and a user. And we'd have this belongs to relationship. And in Laravel 4 world, your user just lived in the global namespace. So if you said user, it would know that is a user object. In Laravel 9.2 world, you need to use the fully qualified name of the class, which would be @model user. And of course, if everything's in the global namespace, this is basically the same as that if it was in there. But because things have moved, we needed to make sure that we're updating this string to something that looked like that. But although our initial code, we use string versions, in some code, we still use the user : class. So we didn't need to update this. So we couldn't go through every belongs to method and just take what was in there and convert it to the new way, because some of them were already using the correct way. So what we think about when we're creating a Rector rule is what code do we want to change, and what code looks similar, but we don't want to change. So this is one example, the belongs to where we're already using the const fetch. And the other bit of code we wouldn't want to change is if we were not in a model. So if we had something, a call to belongs to, but not on a model class, and that's a string, we want to leave that unchanged. So we've kind of got, this is something we want to change, and we've got two examples of things that we don't want to change. So what we do is we run Rector with custom rule, we give it the name of the name of the rule, and it creates a whole load of automatically generated files, including places for tests to live. So I called mine fix model mappings Rector. Maybe not the best name, but there we go. And then we're going to set up our test fixtures. So the first test fixture is the one that we want to change. So we have our old code, then we have 1, 2, 3, 4, 5 dashes, and then the new code. And what this means is that to Rector, this will look at this, and it says if I give this code, run the Rector rule, I expect it to look like this. And if it doesn't, I'll tell you your test has failed. The Rector isn't doing the right thing. And for code where we don't expect any change, this would live in a separate file. We just put the code that we don't want to change, and there's no dashes, and there's no alternative code. So what this means is Rector will give it this code, run the rule, and it will make sure that it hasn't been altered at all. And then we need to, so that's how we make our test cases, and I always start with them first. And then we need to create our own Rector. So the Rectors extend abstract Rector, and we have to provide two implementations, get node types and refactor. So to do the get node types, we need to understand something called the abstract syntax tree. So when we're running code in PHP world, it starts off as our PHP code that we all recognize. And it goes through a number of steps. The first step is a tokenizer. I don't know much about this stage. It just takes the code and breaks it into small chunks. And then those small chunks are converted into something called an abstract syntax tree, an AST. And then when the code is run, the AST is converted to opcodes, and then the PHP virtual machine runs the opcodes. Now, the bit that we're interested in is this abstract syntax tree. And an abstract syntax tree is a graphical representation, it's a graph of our code. So if we had code like this, we've got class, there would be a node in our tree called a class node, and it's got properties. It's got this flags property, which we'll talk about later. And it might also have child properties. So for example, it's got a name, and the name is of type identifier, and the identifier is node type identifier, and that's got a property name, which in this case is car. So we can see how this code relates to the code above at the top, or this tree relates to that. And then we can see it's got some statements. So we've got a class method, we've got two class methods. One of them is for the users method, and the other is called another method. And it's got the flags here, and the flags are set to 1, which means these are public. And if it was protected, I think it would be 2, and if it's private, it would be 4. Or something like that. But the flags determine the visibility of these things. And then if we went into if we had a user method, so this is the thing we want to change. We've got public function is a class method. It's got flag value of 1 because it's public. Again, it's got a name field, which is an identifier. And it's got some statements, in this case, a method call. And there's this library called the PHP parser library, and this holds PHP representations of every single node that you can have in the abstract syntax tree. And we'll look at them, we'll look in some of the files in there in a bit. But the key thing from this section really is all PHP code can be represented by the abstract syntax tree. The AST contains lots of different nodes, and the nodes contain information, and each node has different sets of information depending on what type of node it is. And what Rector does is it goes through the entire code base, and it will say things like, I've got a class node type. Are any rules interested in the class node type? And some will say, I'm interested in that, and it will pass it off that node to the rule, and then the rule will either refactor it or will leave it the same. So our first question is, what node are we interested in? Or what type of nodes are we interested in? And we're interested in code that looks like this. And in AST world, this is called a method call. And if we look, remember I was talking about the PHP parser library, we can go and look at method call class in the PHP parser library, and we're really interested in the public properties. So what we've got here is we've got $var, $name, and $args. And what we can see is $var is the expression. So this is the thing before the first arrow. This is whatever this is. So in this case, it's $this. Then we have a name, and that is the name of the method. In this case, belongs to. And then we've got args, which are the arguments that we are passing as part of the method call. So we've got code along the bottom, and we can see how it relates to the method call in the PHP parser library. So our first question is, what nodes are we interested in? We can be in vector world, we can be interested in multiple kinds of nodes, but for this particular example, we're just interested in the method call. So we're just saying, we're returning an array which just has got method call : class. That's all we're interested in. So the only nodes that will get passed to our custom rule will be method call nodes. And then the other thing we need to fill in is this refactor method. If we return null, then it means we're not going to make any alterations. And if we return the node, then that will replace whatever node is passed in. So this is how we change the code. So if you think about what we're asking, we're saying $var must be an object that extends model, name must be belongs to, and the first argument must be a string. And if all of those things are true, we're then going to modify this node, okay? So our first question is, in the refactor, is var an object that extends model? So we do model type equals new object type of the model : class, and then we can just say this is an object type. So is this node var the same as model type? That's what that means. That's asking, is var an object that extends model? And if it isn't, we return null, because that means we're not going to make any changes. Our second thing is the name belongs to. So this is, we can just use rectors is name, and we pass it node name and say is it belongs to. If it isn't, we're going to return null, because we're not interested if the method name we're calling isn't belongs to. And then we've got the first argument is a string. We've got to do a bit more complicated stuff going on here. We are getting the first argument. We're saying, is it an instance of argument? If it's not, we'll return null. And if it is an argument, then we say, is the value an instance of string? And if it isn't, we'll return null. So that means if we've got this far, we found a node that we want to alter. So then what we need to do is we need to modify the node and return it. So first of all, we're going to get the fully qualified name. And remember, we've gone from user as a string in the namespace, in the global namespace, and they all move to app models in this particular example. So we're going to get the fully qualified class name. So we're just going to put app models in front of whatever it was. We're going to take that. Use the : class is a class constant fetch node. So we're going to give it the name of the fully qualified class name, and the identifier is going to be : class. And so we're just updating the first argument that we found. We're updating the value to this, and then we return the node. And then what that means is Rector will say, this is a node I need to update. So the full, and it will, if we run it, it would go and change everything that we needed to change. So I don't really expect you to be able to read this, but the fact is the rule isn't that long. You know, it's not actually that much code. And okay, that might be a bit complicated the first few times you do it, but once you get used to this, it is, it's quite quick to write something like this. And you've got all the test harness there to make sure you're doing the right thing. So I think if you're doing these big projects, it is worth investing a bit of time in understanding how this all works, because you can do these kind of refactors pretty quickly. And if you want to learn more, there is this good book called, written by the author of the tool, which you can get. You'll have to Google it. It doesn't cost that much. And if you want to see the example, you can find it on my GitHub. So, so the execute step really is just implementing the plan in small focused steps. Do the absolute minimum you need to get from where you are to where you need to be. You can do all the clever extra bits that the language gives you. That can come later. And if you do need to use a tool called Rector, it's worth investing a little bit of time. In fact, this can help you out even just on normal projects. You don't have to be waiting for a big upgrade. And that's it. So that's kind of the process that we went through. And it took us, I don't know, maybe 25, 30 person days to do the upgrade. And I will say that if we didn't have the tests, that number would have been a lot bigger. So yeah, if you haven't got tests on your codebase now, start introducing tests. They will pay back. And it's actually when you do a process like this, this is when you realize just how valuable a good test suite really is. So I'd just like to finish up with a few thoughts. The kind of projects I've worked on, they've all been going for a long time. We've got some that have been going for 12 years. This particular one had been a decade. Another one's kind of 7 or 8 years. And it doesn't matter how much you like whatever framework you like. If you're going to use code that goes for a long time, you need to decouple your business logic from pretty much anything else. The more decoupled it is, the easier it is. So sometimes frameworks make things very easy to do, but it is a lot of short-term gain. It's like having that 4th pint on a night out. You know, it's great and it's fun at the time, but the older you are, the longer that suffers, right? And the older your code base is, the more little hacks you do or the little quick wins you do, the more that will make you suffer in the long run. So really, you know, we need to keep all of these things separate because they all have different life cycles. So your framework will get a new release every year or every 6 months. Your PHP version will get a new release every year and they become outdated every 3 years. Your business logic should only really change when you have new business requirements. Your external libraries might change, well, depending on the release cycle of the external libraries. So for example, we use Zendesk for raising tickets. And every so often, I think that's changed its API maybe once every 5 or 6 years, but it's completely different timeframes to everything else. So these things are all separate because they all have completely different release cycles. And the longer you want your project to go, the cleaner the separation between each of these things is, or should be, to make your life easier. Now, there will be some things that you do where you think, am I going to rewrite an implementation of money when there's a really good set, or date time stuff when there's really good libraries there? So if you are introducing it here, so it's quite tightly coupled to your business logic, the question you've really got to ask is, well, what would happen if that library goes away? And I mean, there's several options. If it's open source, you can take ownership of that library. But what you might think is, if I'm going to go from one library to another, maybe that's something that Rector can help me out with. So you need to ask, how tightly coupled are you? Maybe you'll put a wrapper around the library. I'm not saying you would, it depends what the library does. But for example, things where we're talking to Zendesk, we just have a thin wrapper saying, I want to raise a ticket. And then we've got some code on the other side that actually is the Zendesk implementation. So these are all ways of decoupling what we're doing. And you can just think, isn't it great? Somebody else has written a library that does exactly what I want. But every library you take on is a potential liability. And the longer and longer your project goes, the more, that is potentially more of a liability, especially if it's a project that only has 1 or 2 active maintainers on it, because they could get fed up. And then suddenly it could be something like that, which you're critically depending on. So think very carefully about your dependencies. And one way of kind of reducing the dependencies, for example, we've got some code that sends text messages, but we use something pretty simple like this. It's send a message, who it's to, and what the message is. And this is all that my business logic knows about. And of course, then I can have a real implementation. And that means if anything changes, like instead of Twilio, we go to IntelliSoft, well, I've just got to change the implementation of this. Or if they upgrade their versions, I just need to up the implementation of this. And my business logic doesn't change at all. So that's one thing. And of course, if you really, really do love your framework, then ask yourself what it looked like 10 years ago. And do you love that framework? Because the answer is probably no. So if you're making the code that goes around a long time, try and decouple. But there is one other thing. What if we wanted to do major upgrades? So in Composer, if you do an upgrade, it will not go above. If you've got 1 point, if you depend on 1 point something, you can't go to 2. But imagine if we could codify a lot of the checks that we need to do, and we could codify the automation as well. And maybe then we could put this in a Composer JSON file. So maybe we could have a version upgrade. So you're saying if you want to get to 2, assuming the previous one would have been 1, well, there's 2 phases. We can have a validate phase, and the validate phase might be things like, oh, you run this PHP stand, so you say PHP stand : and then it would link to the PHP stand library. And then what could happen there is Composer could automatically go, we need this PHP extension. I'll bring that in, I'll run PHP stand, and I'll report any errors. And if there are any errors, it will stop and it'll tell you you need to do this. You could have scripts. So these could just be bash scripts. And then it would link, check out my upgrades, V1 to V2 checks. And again, if that exits successfully, it's fine. And if it doesn't, then the script should print out some warning to the developers to say, this is something you need to do. And this validate could have any number of things in it. And then once these all work successfully, you could then apply the upgrade scripts. So the upgrades will go, I need to run this script. I need to run this vector. I need to run this script. And once they complete successfully, you've gone from version 1 to version 2. So the great thing about the PHP world is we have all of the components to do this. We've got Composer, we've got PHP stand, we've got scripts, we've got vectors. We can pull all these bits together. And if we want to, we could probably start doing something like this. You'd have to think very carefully about how you developed your code as like a library or framework maintainer. But I genuinely believe this is something that we can do. And then upgrading from version 1 to version 2 isn't something that takes months and months. It could just become a Composer update. And that is it. I've been Dave Liddament. Thank you for listening. Any questions? Oh, yeah. Oh, yeah.
How many bugs were there when it went live?
There were 3 majorist bugs that got through. So I hadn't said the project. There were 3 bugs, and they were found pretty quick by customers within like a few hours. I mean, arguably we should have found them. Well, of course we should have found them. And the bugs were all the bits which didn't have tests, which is as expected really. They were they didn't have automated tests, and when you're doing the major release, we did try and release it at a quiet time. There wasn't really a quiet time, but we released it right at the start of the day when all of us were in to kind of firefight for things like this. But yeah, 3 like pretty critical things got through. A lot didn't go through our testing, but customers are the best people for finding bugs. Any others? Yeah.
How many custom rector rules did you end up building for this project? And have you released them?
Haven't released any of them because they were so specific to what we were doing. I think there was maybe 10 or 12 custom rector rules and then a load of configured rules. But they were so bespoke to what we were doing that I don't think there'd be any value in releasing them. And that one I showed you potentially, but even then it's probably too dangerous to put in the wild, unless people, have that really bizarre use case of going from 4.2 to 9.
Did you iron out your database relationship fuckeries that everyone seems to have in versions where someone's named it wrong or it hasn't? Because obviously with Laravel you've got the conventions that you follow to make sure you're IDing things and created apps and that kind of stuff, but often there'll be a funky way of having a relationship which then you need to do in your model, like adding the extra things that you don't usually have in your belongs to much of that, or were you quite strict with the database side when you were doing?
I think with the belongs to things, we pretty much did it the way they told us, Laravel told us to do it. So I can't recall.
Because I don't think that's changed an awful lot.
Yeah.
It does make it more difficult if people
Have changed it.
familiar with the conventions.
Yeah. I think in that case, we had stuck with the convention because so we hadn't shot ourselves in the foot in that way. We had in many other ways, but not that way. I can't recall any trouble around there, to be honest. It's a couple of years ago now. There might have been something that was. There were plenty of nightmares, but I can't remember that particular one.
Did you do a code freeze or anything like that?
Oh, yeah, the code freeze went on for slightly more than a calendar month. The code was pretty stable before we went in, actually, in terms of there weren't many bugs that we weren't going to fix, that needed fixing, if you see what I mean. But again, I would definitely, the code freeze was at least twice as long as it needed to be because I didn't think about breaking things down. So yeah, but it was, might have been 5 weeks. We'd just done a big release of stuff and it was planned that there would be this pretty steady bit. But yeah, sometimes you just don't get the luxury of having, that length of time as a code freeze, yeah.
Have you subsequently released as well? Have you given up today with your Laravel shit?
It's gone to 11 and it almost went to 12, but there was there's some trouble. That's not our fault. And we decided we'll wait for someone else to iron that out. Yeah. Yeah.
It's not like it hasn't been supported for 5 years.
Well, I think there's some specific problems with, we were just talking about it earlier, weren't we? There's a point release that caused a lot of trouble at 12, so we just haven't bothered with that yet. Wait for someone else to fix that. That's the other thing I would say. I would always do releases at least 3 months after. If it comes out in, whatever, Feb, do it March, April, May, when everyone else has sorted out the bugs. Don't be the early adopter, yeah. Yeah, sorry. No, we didn't. We haven't. We were actually quite conservative about removing the remaining tombstones. And actually, now it's been in production for a couple of years. I think I feel a lot more safe. We do remove the final ones now because they are there. But we were pretty conservative about it. We did see things again. Oh, remember that feature that we spent hours arguing over and we never used it. But I think that happens in every, especially in startup code, where you're just trying ideas. But had we, actually there is something slightly ironic. We we removed the rector that removed the tombstone thing, so we had to put that back. That was don't tell people that, but yeah, that was. Well, I've got this script to remove them all, and suddenly, where's the thing gone? Oh yeah, we removed that. So, but fortunately, it was all bagged up in a single Git commit, so it was easy to get back to. Oh yeah, sorry, yeah.
Well, you mentioned quarter end. Did you plan your release so that it was near one of those, so that you could spot that kind of bug?
No, that's just sheer chance. Yeah, I'd like to. That would have been a really good idea. But no, not that clever. Anything that looked clever is purely by chance. Everything that's stupid is our stupidity. Yeah. Any more for any more? Yeah.
Were you aware of PHP mess detector package at that time and why you haven't used that code?
PHP mess detector. I think that's a bit of an old static analysis tool. It's a bit too false positive-y for me. Yeah, yeah. I think, I use PHP Stan and I think that's much better.
Yeah.
I mean, PHP Mess Detector was good for its time, but...
Yeah, I mean, but it has a specific feature for removing that code or identifying that code.
Oh, does it? Yeah. There is another way you can remove the dead code. There's a plugin for PHPStan which looks through everything and it will tell you code that isn't called. But you would still really need, so anyway, it will look through the entire call tree and tell you stuff which hasn't been called. So you can remove that. But you would still need, I think, the tombstone approach for controllers and commands, because you have to assume that they are called until you know otherwise. I mean, with controllers, I suppose you could look through the logs to work out if they've been called or not, but it's probably easier just to put tombstones in. But yeah, no, I haven't checked out the mess detector way of dead code. No. All right, any others? Okay.